And we are recording. All right, so tonight we are talking about about chapter 6 in Refactoring by Martin Fowler. This is the first set of refactorings, although we've seen a lot of them in the previous chapters. So it was a good opportunity, I think, if you hadn't been skipping ahead from references in other chapters, to just look at them holistically and see, what are all the steps involved, like what are the mechanics, what are the rationales, etc. So as this is the catalog, I've talked it over, and instead of this week being a more ad hoc discussion, we're going to go kind of round table style, and everyone can talk about one that you either saw this week or have seen, frequently in your career, or one that you just kind of read and really were interested in. Just anything that you think about. It doesn't have to be super. It's not like a presentation, like we're not giving you a grade or anything, but just, it'd be good to get the discussion going that way. So I can start if you would like, or if anyone wants to volunteer. Someone wants to volunteer. Jeremy said
no, I was going to say, go for it.
I think the manager of the group should really lead this discussion.
Oh, I see. I see how that
really set the agenda, so that way we know minute by minute of how it's going to go.
I see. Okay, cool. So I liked several of them in there. The first one, talking about extract function, that's probably the one that I use the most, just because in general I think it's the easiest one to really understand. But I did pull a couple of things out of the change function declaration that I thought were interesting that he talked about in the book. So just if you didn't happen to look at that one, the gist of it is basically it encompasses all of the things that you could do to a function declaration, including changing the name as most basic form, or dealing with parameters. So introducing parameters, removing parameters, that sort of thing, just kind of changing how the signature of a method or function looks. And one of the most interesting mechanical things that he said in there was that a good way to improve a name of a function, and this applies to variables too, is to write a comment. If you're looking at it, just write a comment that describes what it does or describes the function. And then from that, you'll extract what is the actual purpose. And then you turn that into the name. And so I think in that refactoring and several others, he did a technique that I find myself not doing, but I think I should, based on, just kind of seeing it, in where he was putting, like, he was going to rename a function or rewrite it. So he wrote one that was like, XX replace me kind of naming. And so it was very, very obvious. And so in his work, or in his process, he'd make a new function and start like kind of as a stub and just say, there it is, it's got a new name. And then now I'm going to make the old function call that one. And then you're not breaking any callers that are using it. And then just kind of work the refactoring that way, which I think is pretty smart. I think I do that a little bit, just based on experience, but I don't feel like I'm very methodical with it. And I would like to change that, because I could see the way he presented it working out a lot, or reducing the amount of time I spend, chasing down things that I've broken because I didn't do it very methodically, or because my tool didn't catch it, or whatever happened. So I think that was probably the most interesting one out of the group for me, was just really, really diving into all of the different ways that, how you evolve an individual function through that declaration change. And then the other interesting bit that I took out of that was parameter. So he talked about like parameter consolidation. So you've got like a bunch of examples that are along the lines of you've got like a parameter object, that sort of thing, or you've got like a map set of coordinates, and so you've got like an X and Y, that like multiple parameters, and working all of that together. And I think I know I do, and I know a lot of other people do, kind of lean towards passing the larger object in, just because you're like, oh, I need to get the shipping address, so I'm gonna just pass the person in because they have a shipping address and makes it easy for me. And I've got this one little thing. My method signature is short. It makes everyone happy because they just need to see, oh, you passed in a person or whatever the order, whoever the user is that ordered, and I get the shipping address. But I think that leads to a lot of inflexibility. And that was, I think, the key point that I took out of that was his example was around phone number formatting. So you have a function that formats a phone number. So it would be like format phone number, pass in a person, and then you pull the person's phone number and format it. But then what happens when you have an order that has like a phone number attached to it, or you have a company that has a phone number attached to it? So just kind of shifting the declaration that way leads to a lot of code evolution. I think that this is fundamental. This particular refactoring, I think, is fundamental to the idea that your code should evolve to handle situations that you hadn't thought of. And so from that, I'm taking like, look at the lens of what are the parameters in the function? What's the name of it? So what's the purpose? And then do all the parameters make sense to achieve that purpose? So if the purpose is as simple as formatting a phone number, should I really be passing in a person, or should I be passing in a phone number? So I think that's kind of the key takeaway from me from that particular one. And I think I've rambled enough now to satisfy my manager quota. So who wants to poke holes in what I just said?
Maybe you need to pass an address.
Pass an address?
Neither just the phone number, not the whole person.
Yeah, that's true.
Yeah, yeah. So for me, it was one of the latest and the one of the last ones. Combine functions into class.
Mm-hmm.
So I think it's kind of very powerful, right? That you have all of these little functions, and they say, oh, these kind of are working on the same body, on the same data. So we can even put it in the same class, and also with encapsulate variable. So, okay, all of those functions and all of those, the data is a new class, right? So that sounds to me very, very good. Yeah, I have another one, but yeah, I leave it for, I want to use all of them. But yeah, this is especially when we have, when we can extract, right? So he keeps talking about extracting functions, extracting things. So if we can extract that class from a huge class, right? So okay, I was thinking it's like a body, right? Like a person, right? Okay, you have a full body, but we have an arm, we have a hand, right? So we can name those specific parts, right? So it's kind of the same principle. Yep. Thank you.
Totally agree there. Yep.
I just thought of something related to what you were just saying, Jeff, about passing in only the phone number instead of the customer or the person. I can't remember specifically what it was. And I agree that's a fantastic example. I love that example. But it struck me just hearing you talk about it. It's almost like the interface segregation principle. That principle is saying rely on the smallest thing. If you have, the lowest level interface, if you have interface A extends B, C, and D, and you only rely on a single method from D, you should only type on relying on interface. It's almost the same thing, but just expressed slightly differently.
Yep, definitely agree with that. It's like if you're passing in something that you're expecting to be able to count or sum or something like that, and you've got interfaces that hint on this thing is countable, it's much easier than passing in something that's implements that a much higher up in the stack, and then you end up with, well, now I need to count this thing that isn't one of those. How do I do it? Let's write a new method, and then you end up, yep, totally agree. I didn't think about that, but that very, very good point.
That same kind of thing reminds me, you all did a book club on this, and I actually haven't read the book, the domain-driven design book, but I did see some sort of GIF or GIF or whatever you call it on Twitter. And it was showing kind of how, I guess, part of what they really recommend you do is that between boundaries, you always have like a switch in the data structure. So you always change the data structure between boundaries to like really delineate. And it sounds like that principle is also very similar here. Like whatever you define your boundaries, you want to make sure that you're transforming the data in the way that it's exactly what you need, which is, making the arguments or the objects passed to the arguments smaller to be exactly what the specific function needs or method.
The problem is when it's not that cut and dry, right? For formatting a phone number. Okay, we just need a number. But sometimes it's not. You don't really know at the beginning what you're going to need. Right? Yeah, that happens in the thing I'm doing right now. So, okay, we need to calculate this, but okay, it seems like we just need these specific parts, but it's not really completely clear if that's the only part we need. So it seems it's safer to start with the whole thing, and then, okay, I just need this. I can refactor to just use that specific part.
Yeah, and I think that's fair, right? I think that's part of the whole process of, you know, if you don't know, and a lot of times you don't know the first time you're writing something, like what specific pieces, and then you may even have other pieces in here about, like, you know, you're dealing with parameter objects, and like they may not exist yet. Like you may not even know that that's a thing that you need to like group data together. So I don't think it's bad to have that as your first attempt, or even to see that in your code base. Like I think it's totally acceptable. I think the larger point is just when you get to the point where you're seeing a need to format phone numbers that are not attached to people, that's when you should make this refactoring. So I think this boils back to something that he said in an earlier chapter that was like, you know, don't refactor for the sake of refactoring. Refactor because you have an actual concrete need. So I think I would say most code probably starts with, you know, hey, I need to format this person's address or this person's phone number. So I pass the person in, and it's until you're looking at it from a different standpoint or a different perspective, trying to understand what it's doing, or now you have this other object that has a phone number, you need to format it. That's when you'd see that. So I think it's fair. I don't think that's a problem or indicative of anything.
It's like he said earlier in the book, where as your understanding of the code changes, that's when your code will change. And so your initial need there is, oh, I need a phone number from this person. But as time goes on, now suddenly that phone number takes on a new context, and how you get it and process it is different.
And I would bet in a lot of apps, you never ever have to make that refactoring, because you only ever format that, depending on what your app is doing, like it may only ever be a person that has a phone number. And so like you would never even see that come up, like it would never enter your perspective.
Yep. For me, I was actually kind of surprised. I wasn't sure I really got it at first. And then I'm thinking about it more. Maybe I still don't get it, and you can all tell me if I got it. But one that I thought resonated with me was split phase, because I just encounter a lot of, I do this all the time. I realize I am splitting phase constantly when I'm working with code, because I work with a lot of really long methods, and I just can't mentally map what is happening in these things because they're doing too much. They don't follow sync order responsibility principle. They're like, I'm ultimately outputting something, but I have to go do a bunch of different things, and I didn't take the time to put all that different logic in separate methods that then produces that output. And so it was kind of nice to see that example and think through it, where, yeah, you know, you've kind of got this long thing, but you're breaking it down into smaller parts by kind of, pulling out the little bits into smaller pieces so that you can get that end result. And that was kind of nice to see. I did a bit of that this week in my own work, like trying to refactor something I was pulling into my own project. And it was just kind of nice to break it down into smaller bits and kind of follow along what was going on.
Yeah, I think so. I know I definitely do this one a lot, even though I don't think I've ever given it a name or even thought about the fact that it has a name. But like, a lot of times you encounter something, and for me, it's usually like a huge long method that has a bunch of stuff that's grouped either weirdly, like to reading it, or it's doing something that feels very like procedural, like do this, now go over here, ask this person to do that, now let's go back over here. And so it feels like that, well, I guess as it's described, splitting phase, right? And so like what I tend to do, I think mechanically, is just I'll go into the method and I'll like put in huge vertical space in between the things, and then just kind of see what can I rearrange, what variables can I move, what what things belong in different methods, what can I extract, and kind of I think this is probably the one out of this chapter that's more of a, for me anyway, like a combine all of them together kind of approach, because it's like, it's complicated. It has everything from renaming variables all the way up through the more complicated stuff of combining stuff into classes. And so I think it's a real good one to deep dive in. But like I said, like I don't even know that I've ever identified it as a singular thing that I was doing. It's more like I don't get what's happening, so let me logically, visually separate these things for me. And then that's when it turns into a refactor fest of extracting stuff and moving stuff around. And his favorite like slide statement thing, which I was like, you mean copy paste? Like I've never given it a name. I guess slide statement works if that's what you're into. Yeah.
Well, and I think split faced itself too leads to new refactorings, because now you've gotten to that place where, okay, I understand it. I've changed this and made the structure a little cleaner to follow. Now what else can I do? What's next? What's the next thing?
Absolutely. And that's the downside of refactoring. It's like I guess you could say like rename variable is a gateway drug, right? Because like refactoring is definitely an addiction. That when you catch it, you're like, oh, let me just go in and I could change this entire code base just because I can. And then it's like, well, maybe I should be doing something else because I have this other work I need to deliver. But this is so much fun. Yeah.
Would you argue that, unlike most other addictions, this one is actually good for your professional health?
It could be, yeah.
I don't want people to watch this later and be like, oh, hey, now they're saying don't refactor. It's addictive.
No, that's not what I'm saying. Everything.
No.
Okay.
Yeah, except when you don't deliver.
Yeah.
For sure.
If you're you should be delivering on what you're supposed to be delivering on. If you can, you should also be refactoring while you're doing it. But the only thing you deliver should not be refactoring stuff that was not in scope of whatever you're actually supposed to be delivering. How about that?
Yeah. I think Jeremy just posted a message in the chat saying everything in moderation, and I think that's probably a good mantra. I was going to say that. Oh, you go ahead, Gerardo. You go first.
I was just going to say about split face that I also think that I do that very often, and I think probably most of us do. But what I found interesting is that I've never used the specific mechanic that he uses, the whole identify phase 2, move that over first, then start identifying what things from the initial code base are part of the arguments of that new function, and then starting to collect some of those into that middle data structure again. That is effectively going to be what phase 1 does. So the phase 1 possibly enriches or creates this data structure that then gets passed to phase 2 on top of maybe a few other things. But I've never done it that way, and I want to go do it that way, see if it feels better or it feels safer or whatever, because there must be a reason why he starts with phase 2. And I imagine it's because of that middle data structure, because you want to see what's necessary at the end to be able to encapsulate the middle versus doing it the beginning first, because all sorts of crazy things could be happening at the beginning and you don't realize what the end really needs or how to cut those in 2 pieces.
Maybe that speaks to one of the really interesting things for me reading these refactorings is that just how much now our tools have come along in the last 20 years. You know, that he describes how you would do it methodically in Vim with no plugins or Emacs, and that's awesome. But I'm sure the majority of us now, we just highlight a bunch of lines and go extract function, and the IDE takes care of everything like this for you, right? It's really interesting.
The downside of highlighting extract functions is then you open a PR somewhere and then they're like, Jeremy Ward is like, oh, union types, I have many users. I was like, oh, I didn't even intend to even put that in there. I just highlighted in PHP Storm and said extract, and it just did it for me. Like I didn't even look at what I was doing. So yeah, it's kind of it's a good thing and it's a bad thing, right? Like our tools are great, they're advanced, but they also do things that, you know, I think with the like methodical, like intentional kind of process that he's outlining. And to your point, Gerardo, I think I agree with you, and I think it would be cool to even, you know, look at every single one of these and just, instead of doing it my way or instead of right clicking or, you know, keyboard shortcutting, to just physically do the change and see, like, is his technique close to what I was doing and just didn't realize I was doing it, or is it better? Like, am I just doing it wrong when I do it, or is it personal preference? Like, it may be personal preference about how he thinks about like the phase 2 alignment, and like it may not even work in your brain, right? Like it.
Yeah, I was going to say the one that really resonated for me. I mean, I enjoyed this chapter. I thought everything was fantastic, but the one that resonated for me was introduce parameter object. And briefly, I mean, the description of it is you have a bunch of methods that accept the same, or arguments which represent the same data. So why don't you just extract those pieces of data into an object? The thing that I found so powerful about this one was the heuristic that it becomes by grouping the things together and giving them a name, you begin to see how you can move the behavior there as well. And that's something I don't do enough. Like, that's something I'm definitely going to start doing this week or whenever the next opportunity comes up. The funny thing is, I've read this book before and I highlighted exactly those comments, you know, around this, and clearly I highlighted it and then forgot all about it and never did it. But reading it again, I was like, oh yeah, you know, past Jeremy was actually clever. He did highlight this, but then just didn't do it. But that's something that I hadn't really thought about in terms of like, as a way of generating insights into what the structure of the code should be and making that happen. So that's something I'm definitely going to be doing more of.
It's interesting you should say that. I wrote down introduce parameter object. I don't use this as often as I should. That's like the exact words that I wrote down. And it's kind of funny. Like, it's,
yeah,
totally agree with you.
There's kind of an opposite to it that's not in this chapter that I'm hoping is going to be covered in a future chapter, and I assume it will, which in my world, I see a lot of cases where not a parameter object, but you have a parameter array that just has all the stuff, and you want to maybe split that out, and you know, maybe that gets into change function declaration. You know, you're actually passing in just the things that you need, making it more clear what those methods are going to need. I'm not sure if that's going to be covered like in that kind of like circumstance in the future, but I'm looking forward to seeing if it's in the future chapter.
Right. Yeah.
That's the double edge of the practice of keeping your method signature short is, oh, I could just have everything into an array or a hash or whatever your whatever your language supports, and then you end up with, oh, well, in order to make this work, you have to have this magic structure that is only written in a comment somewhere, and good luck figuring it out.
Yeah.
Been there, done that.
Guess I haven't spoken up yet. I liked in change function declaration when he talked about published APIs, because I don't think people think about that enough, at least in my experience. And, you know, when it's public, it's not so straightforward. It's not so easy because you don't know how many people are using the old thing. Maybe they like it that way, who knows? And, you know, how you have to be a lot more careful there, and, you know, deprecate the old one, eventually get rid of it. He said, even I think in one point, like maybe you never get rid of it, but there's a nicer name, you know, introduced to the code base that, you know, you would prefer, or maybe, you know, it's a better, you know, function signature. But yeah, I don't think that's talked about enough. I mean, there's topics about how to manage APIs that we can go into as well, but I like that at least briefly he talked about it there, because that's where it really, you know, becomes complicated. And that's why I appreciate that one, because of its complexities, but especially because he thought about, it's not just within my code base, it's whoever else's code base might be using this. So I really like that.
Yeah, it's all fun and games when you're the only consumer, or when you or your team is only consumer of what you're writing, right? Then you end up with, I've seen like, especially in like Ruby projects, like you have this one class that effectively is just a giant thing that delegates to a bunch of other like modules, or it's, you know, like you pass the one method has like a parameter, and then it just calls this other thing on this other module that's like 15 parameters. You're like, wait, what happened here? And then you can go trace it back as, you know, some other thing was depending on this. So it calls this one method, but we've changed our minds about where it should be, how it should be organized, what it should be called. And so now you've got this maze of backwards compatibility delegation effectively. So good times.
That kind of reminded me of the whole debate about protected versus private methods in classes, and how some people are like never private, always protected, and some other people the other way. And I guess the reason why it reminds me of that is because, in my opinion, a protected method is almost like a public part of the interface. Like you're telling people, hey, when you extend my class, you can change this stuff. But when it's private, obviously you cannot. You have to go through whatever my filters are part of that interface, even if you extend the class. But yeah, it's tough. But I mean, when you're having to support that and having to think of like, okay, who all have extended it and overridden these protected methods, what am I going to do about that? Like, it just makes everything way more complicated. So yeah, hooray for locking everything down and just being very selfish about what you expose.
It's like the
Yeah,
least,
clear.
the principle of like least permission, right? Like you give nobody access to anything, and you're like, come ask me when you want something, and then I'll consider making it protected. Yeah. Sorry, Antonio, you were going to say something.
Yes, I was going to joke that you declare those protected methods, but the class is final.
Nice.
One question and comment. So I was reading this chapter, and what I was finding is, okay, we have these 10, 11 refactoring ways, right? And in basically all but one, it was very clear and kind of the mechanics, I think Gerardo was talking about that, but the mechanics felt unnecessary. Like, okay, yeah, we can extract a function or method. Okay, we can, it's kind of very intuitive. So it looked like noise. And then for the refactoring that I didn't really completely understood, that combine functions into transform, the mechanics didn't help either. So I don't know if it's something that happened to you.
Well, yeah, I mean, to your first point about the mechanics being noise or seem to be a little too much. I wonder if his approach, I mean, again, if Martin Fowler was here, we could ask him directly what he was aiming for, but I wonder if his approach is to go into as much detail as he can, knowing that most of the times you won't need that detail.
Mm-hmm.
But it's there, like, for example, if you try, I don't know, rename variable, and it totally failed, then you could go back and say, well, here are the mechanics. Let me see if I can follow this through almost like a recipe, step by step. Maybe that would work. So I wonder, yeah, I mean, I know what you mean, like, because some of these, it's like, this is so simple. Why do I need this list of 5 mechanical steps? But I think maybe it's there for those times when it all goes wrong, and you do need that kind of little more hand-holding. I don't know, does anyone else get that same kind of thing?
I think so. Like, to me, it seems more like the, how do you ride a bike kind of thing? Like, at first the mechanics of, okay, how do you get up on it? How do you put the kickstand up, or, if you have it, whatever, like, like the whole, like, okay, now push this, now do this, now shift here. And like, you have to learn all that as you're going through to understand how it works. But eventually you get to the point where it is all noise. Like, it's just second nature, and you even feel when to shift, or you feel like how to do everything. You don't need anyone to tell you, hey, now's a good time to do that. So I think it's to me, it's the same thing, like this being more of a introductory text in terms of, hey, I'm describing this thing. Here's how you go about seeing that evolution in the code. And like, I would be absolutely surprised if Martin Fowler actually follows all of these steps every time he's doing any of these. Even, some of them, it was like, do this, put one character, now run the test. And it was like, I highly doubt that anyone's actually doing that. I mean, if they are, more power to them. You're doing it by the book. But like, yeah, I think to me, it's like the mechanics are in this book more to show you, hey, I'm talking about this concept. It's maybe difficult to visualize, but here's the evolution. You can see all the steps, and then you can see why this change is good or whatever. So yeah, I mean, that's my take. I don't think it's meant to be a, every time you want to rename a variable, you have to do these 55 things, because, you know, there's no possible way you could do it any other way, especially now with, you know, tools. So I think it's more of an illustrative point than a recipe book necessarily. And the, you know, the other side of it is it's good that it's in here, because then it leads to the question Gerardo had earlier. It's like, you know, I've done what I think is this thing before. Let me try these steps and see if A, I understood what he was talking about. What is split phase? Do I fully understand it? And then B, do I fully understand the motivations behind it? Even if I know how to do it my own way, maybe maybe looking in and understanding why I do it would be a good thing. And to your second question, Antonio, the merge into transforms. Yeah, I have no idea what that means. If I'm being completely honest, I read it and I was like, I kind of understand, but not really. So I mean, I don't know how to answer that. So maybe someone else does.
Should we hold on to that one till the end in case anyone else wants to speak to that particular refactoring?
Sure.
Just in case, just so we don't jump the gun. But I don't know if I fully understand that. Jeff, I know you were joking earlier when you were like, hey, we can spend an hour talking about rename variable. But there was one very profound point in that, and it was the shortest refactoring in the chapter as well. But one really profound point, and everyone may know this already, but I wanted to just say it publicly. The concept of the wider the scope of the variable, the better the name it needs, was really interesting to me. Like if you're just passing a parameter to a lambda and you're going to use it in one place, just call it A, who cares, right? It's probably okay. But if you have a variable that, or a constant that's going to be referred to throughout your entire application, probably calling it A is probably not a good enough name. So I really like that point in that refactoring.
Definitely agree. That's like when I get, I don't want to say annoyed, but like when you see like you got some kind of pipeline going or something, you got these little lambda function, little short function that's like taking this thing and then call this one, you know, method on it. And so you end up with, let's call it variables I extracted from this object. You're like, the variable name that you have to put in there twice is now longer than the whole rest of the line where you're actually doing the work. No one needs that to understand that, hey, you called map and you've got an object. So like to your point, it could be A, and you understand that I'm mapping everything in this collection that's A, I'm going to call this method on it and return that value. Like no one needs a super long variable. So yeah, I mean, it is a totally good point. And I know I'm personally guilty of like writing very long variable names when I shouldn't, or just because it's like, I think it comes from that whole, I was trying to understand something. So I renamed a variable to something really long, or I wrote it really long to begin with. Cause I was like, I don't know where this is going to evolve to. So let me just name it something, but maybe the refactoring should go backwards in that case. Like I write it really long when I'm writing it. And then I say, oh, never mind. I didn't need to give everyone 5 chapters worth of context to understand that this is just the y-axis parameter. So I can call it y or y-axis, something like that. Yeah.
I think he made the same point or a very similar point in another one of the refactorings, which is, it was about the same thing. Like the bigger the scope of the variable, the more careful you have to be with it. And I think this was actually like that one refactoring that seems very silly, which is like wrapping a variable in a function call effectively.
Mm-hmm.
But his whole argument was the same. Like obviously you probably most of the time won't do this, but if this is some sort of global thing that a lot of places are accessing it, having that function is actually easier. This also connects to the point that you were making about the public APIs, that, you know, if somebody else is using it, it's easier for you to kind of like deprecate a function than it is to deprecate a random piece of data that just lives across all of your code base. So yeah, I also thought that was very cool and profound. It's something to remember.
It's interesting, the encapsulate variable one though, because I came across a really interesting, you're right, in many respects, it's almost something you don't necessarily reach for that much, but I came across an interesting case recently in refactoring JavaScript code. There was a single file that had many, many different functions in it, and many variables were declared that were shared between the functions. So the thing that made that code really hard to work with is you couldn't move functions into different modules and begin restructuring it because they all had dependencies on these variables. So the first step was encapsulate those variables, like moving those variables one by one into their own module, and then adding setter and getter functions. And when that was in place, again, it wasn't where we wanted the code to end up, but it enabled us to then start moving the functions around. And we haven't finished this thing yet, but what I'm imagining what happened is that as we move the functions into different modules, we'll start to see these group of functions depend on this variable. So we'll bring that variable over. And it was interesting because it was interesting as like a first step refactoring that kind of opened things up.
Yeah, that was the one that kind of annoyed me a little bit. And this is the one, for me, weak point in a chapter. So hear me out. So I get the value, getters, setters, all that. But when he talked about the getters, he said, I don't like prefixing getters with get. It's like, I just don't like it. And he never really justified it. I thought, okay, I don't know why. Because the setters, he was fine just, putting set in. And then later, I think it was inline function. Later in the chapter, he's like, oh, if I was going to inline this, then I would call it get, whatever. And I thought, you're just, kind of speaking against yourself. And I don't know, maybe he didn't catch that along with some of the grammar and spelling mistakes I noticed. But that one to me, just didn't make any sense. Like, why not just be consistent? So that one annoyed me, even though I knew the value and I kind of do it all the time. Why not just call it get and set? Everyone calls it that anyway, right? And in the earlier chapters, he talked about things being clear. And I thought, well, if you drop the get, is it really clear what the intent of this thing is? I'm not so sure. So but that was the real weak point for me in the chapter.
Yeah, so I agree with you. However, I'm going to say this. I prefer not putting get and getters. And I think it's because after I started working with Ruby, really extensively, it's so nice to be able to call whatever dot and then just the name of it. And so you have the getters, the setters, and they're all just the same thing. So, and he talked about this later in the chapter about how you're calling an accessor, but no one knows, and they don't know if it's a property. They don't know if it's a function that you're doing something or a method or whatever. And so that's nice when your language supports it, but when it doesn't, or when you have to put parentheses, or so it doesn't read the same way. I put get, even though it pains me. I hate seeing get property, set property. It just drives me nuts. I'm like, why? Why do I have to do this? It doesn't read well. But I so I agree with him, and I think I understand it. But yeah, the inconsistency is kind of rough.
Well, because I thought it was language specific. I thought, okay, if the language supports it, maybe you don't need it. But then later, he's using the same language, I'm presuming, JavaScript. And then he says, oh, I would do it here. To me, it was kind of weird. Why aren't you consistent then? But I mean, I know there's languages that support, the concepts like properties where you don't have to write get and set.
Mm-hmm.
Like C#, I use that a lot. You don't have to, have traditional getters and setters. So that's fine, but then be consistent. Don't put getters somewhere. Don't use properties somewhere else. Because that makes it clear to the reader. And again, I think that's the whole point of this whole book, is making code clear to read. So I thought that was a little weird. And it was the one part where he didn't have a good reason. It's I just don't like it. That then he should have just said, this is personal preference. You can do what you want. He didn't really say, it's I don't like it, so I'm not going to do it. I don't know. I thought that was a little weird.
It is weird. Totally agree.
I wish he was here. I'd pick his brain.
We've discovered one thing though, that Martin Fowler is actually human. He makes inconsistencies like the rest of us.
So what you need to do is you need to get a couple examples together in a couple of different languages, some that support not needing getter, setter kind of syntax, and some that don't, and then figure out a way that you could send very similar examples through Martin Fowler and see if he'll refactor them. And then if he is consistent with his get, set, or not, then we know if it was just an error in the book, or I'm sure he's open to that. There's nothing else to do. I bet.
It's interesting. So I was thinking about Java when he was saying that, and you're right. I mean, Ruby and C# and JavaScript now have got the syntax where you can add getter methods for a property, which Java doesn't have. But I don't know if there is a convention in Java, right? It's. I mean, when you read the method in Java, you could you had a type called person, you probably have public person get person. It's so repetitive. It's very Java-like in that sense. Yeah, it's interesting. I mean, Antonio, I know you do a lot of Kotlin, but does Kotlin have like getters and setters built in for access to?
Yes, they have these data classes,
Yeah.
and basically you specify the properties, and then you get these getters and setters and equals. We're going to get those in Java, right, with the records.
Yeah, I was just gonna say I should just stop writing in Java and start using a less verbose language, but apparently we're getting that too.
Did we get through them all? Any others jump out at you?
I was so surprised that in this first chapter, they didn't add the most common refactoring for me, which is adding blank space between code just to separate blocks that don't make sense. That one's so important.
Can you tell us the mechanics of that one?
Well,
It's like
first,
50 steps. I don't want to bore you.
first you have to run your tests, and then you use enter in your editor, and you don't have it set up, so it puts the wrong indentation, and then your linter tool tells you that you use the wrong indentation, but it doesn't tell you where, and then you that's the general process. Well, I wonder
you
what
realize you're writing. I was gonna say, you realize you're writing Python, and you find out the white space is significant, right?
Yeah, nice. Yeah, I wonder what you would call it. So we have like slide statement, which is copy paste your code around. So we need to come up with a really good name for inserting white space. That's a good exercise for always always run your test to find out if you've written Python. Nice. I like it. Okay, any other serious ones that are not jokes?
So
Talk about extract, transform. Oh, go ahead, sorry.
The second refactoring that he proposes is this inlining a function, right? So he says, okay, we can extract now. Okay, now if it's too small, and we can put it back, right? So something that is a function, we can. So that didn't make sense to me first. So he said, okay, if the what it's doing is as clear as the name of the function, so we don't need to do any redirection. But it seems it was more of an opportunity to have a better name than just, okay, I'm going to start putting that code back. Especially when his previous example for extracting function was this highlight versus, I don't remember the specific method in Smalltalk, right? But reverse, right? That it was more about the intention. So, yeah, it was kind of, I mean, it was more like he was trying to be exhaustive in all possibilities, but in general, I haven't ever done something that I want to put back this.
I think in the example that he used, he's basically making the argument like maybe this function never should have existed because the line of code that's here already is explicit enough and shouldn't really be broken down into a smaller part or its own individual part. So it made sense to me. It's maybe an edge case that you see as, it might be like an example that occurs after you've done a lot of refactoring and you're like, I'm going through this process and I'm going to break everything out. And then you kind of realize like, oh, maybe this is actually easier for me to read because this belongs in this method and it's just a simple conditional. Like there's no other context I need to have here to understand what this is doing.
I think for me, like I don't use this one a lot, but I think it'd be more, I think I'd see it more often or use it more often in the case where something was kind of down that thing we talked about before, like speculative generality case. Like you've ended up making some, you know, some method or something that takes a parameter. And so like in the example it is in the book was about, you know, deliveries or a delivery driver that has more than 5 deliveries or whatever. And so the example method was like one conditional that was like if deliveries greater than 5. But I think more often you'd probably see something was like delivery driver has more than, and then it would take a delivery driver and then it would take like a number of deliveries, or it would have like a whole bunch of other stuff built into it. And then when you get to the refactoring step, you're like, wait, we never, like, this doesn't make any sense. Like, we don't need all this. So then you would say, okay, how do I distill this more complex thing in this method down? And so you'd refactor that down to its most simple state. And you'd end up with that deliveries more than 5. And then that's when you would take that one line and pull it back. I think that mechanic, like, that makes sense, but I don't really know that I could think of like a good example of code that I've written in, you know, the most recent past that I've done something like this, like just kind of pulled something back. So take that for what it's worth. Of course, I don't write that much code. I'm a manager, right, Jeremy?
That's what you tell me. You told me you were a manager. I don't know.
Mr. Manager.
You know, you're
Sorry,
not
Mr. Manager.
you're not the only person who calls me that. Someone I work with calls me that. He's like, "Oh, you're too busy doing Mr. Manager stuff," and I'm like, "No, I'm just whatever. It's fine."
I really like, I mean, I think your point's really interesting. That one thing else, I mean, having read this book before, one thing I do notice a lot of the catalog is that there's a lot of cases where he does, here's this and here's the reverse of it, you know? And I think it just speaks to the fact that there's never there's never a right answer, right? It's always, the answer is always, it depends. Well, one really interesting thing I think about the inline function, the inline method, refactoring that he pointed out, is that frequently it's the first step in pulling things back to introduce a new abstraction. So that maybe that's an interesting case for that one. And I've done that a lot myself in the past. You know, I've been looking at code and been like, okay, I want this to be structured differently, inline everything, and then extract something different.
Yep. I think what would be a good A/B test is print this book in 2 different versions and then swap the order of like whether you put inline or extract first, and see like if, because it may just be a symptom of the fact that you're reading them all together, that it's like really standing out that there is that whole back and forth. But in reality, they're all in a vacuum, right? They're all like, you're looking at code, so it has some symptoms, so you apply some refactoring, and you would never, or I guess I would never look at a piece of code and say, I see someone must have extracted a function here, and now I'm going to reverse that because I know better or something. You know, I would never approach it that direction. So it may just be like the whole recency bias. Like you just saw extract function, and now you're talking about inline it, and you're like, why would I do that? I would never reverse them. It doesn't make any sense.
Well, I think that's an interesting point, because it's not so much that these are recommendations for what you must do. This is a how-to. So if you are trying to change something, so like Jeremy said, if this is the eventual outcome of some other refactor, how do I get from point A to point B in small steps? That inline is that small step. And then now you're going to be on your way to something else. So you're right. It may not be the result of it. Like you're actually going to have that, but it's going to go into something else from there. And it's nice to have that guide, to have both sides of it. I can go this way and I can bring it back. It's like doing a Rubik's Cube. How do I get it back? I still have never figured that out.
Well, there's apps now. So you just take a picture of one face of your Rubik's Cube, or maybe you have to do multiples, and then it tells you what to do. It's amazing. Computers are great. You don't have to learn anything anymore. Just Google it. Or Bing it, or whatever your thing is. DuckDuckGo it. Is that a thing? Can you verb DuckDuckGo? I don't know.
You just
Duck,
did.
duck.
So
Quack,
it is
yeah.
now, right?
Can be.
Quack it. Is that what you said?
If you're brave enough, anything can be whatever you want it to be.
That's true. That is true.
I think like the one thing that he didn't mention as one thing that I really like to do, and I do this with both public APIs and also like internal stuff, is adding circuit breakers. So if I notice a method that has a lot of if else blocks, I will extract as many of those ifs and flip them. So that way, if they return false, I exit immediately, and I will push them all the way to the top of my method. So that way, like I don't have to worry about it falling down and possibly being uncaught at any certain point in time, and rather I just group them all together, catch any potential piece of missing data or false data, whatever it might be, and then just immediately exit instead of executing what could be up until that point, like now worthless code, if that makes sense. And I use that too with public APIs, kind of going back to the topic of versioning APIs, which is a topic that could take hours and hours and hours to talk about. But like I will, as I'm moving API versions, after I've announced the new contract, I've put out the new contract and I've given it 60 days, I've added the sunset header on the HTTP headers, like I've done all of my due diligence. I will add a circuit breaker and let the code exist for a while, but still just return the 400 bad requests or whatever it is for a little bit longer. With maybe a query value that allows people to get around it just for super secret reasons, but it protects the method while still being able to be used in other different ways potentially, while also keeping code from being ran that may not even need to be ran if a false value is immediately encountered.
It's a good point.
I love that technique.
I think if I had to name this one, I would call it like the else defeater or something like that. Like I do this too. Like anytime you encounter something that has, especially like either a really huge if else block or it has like a bunch of nested stuff, I start exactly like what you're describing, which is how many of those ifs can I shift all the way to the left? And then how many of those can I move up to the top and turn them into guard clauses and just kind of return early and get out of here? Because otherwise you're sitting there trying to parse this thing every time you get there. And you're like, what? Okay, so if I did this and then I get to here and now, okay, what now it does this, and you always miss stuff. So yeah, totally good point. And now I'm going to find any APIs that I know you work on, and any 400 bad requests, I'm going to start sending super secret parameters and see if I can get around them.
Good luck.
Nice.
Is it possible that refactoring is going to come out in chapter 10 about conditional logic?
It is possible. I don't know. I haven't.
We haven't seen
read
it.
that
We're just scratching the surface, right? This is the first set.
This is only chapter 6, Jeremy. You're not supposed to read ahead. You're supposed to be on chapter 6, ending.
The syllabus says we're covering chapter 6 today, right? Yeah.
I'm going to make.
I was going to say I love. I mean that exact technique. I love to do the same thing. Right. I much prefer to exit early to return early. Interesting. I read a book on Elixir a couple of years ago and worked through all the examples and really enjoyed it. But one of the really interesting things Elixir has is guard clauses in method declarations. So you can say def some method, some arguments when such and such condition is true. And the example in the book talks about using tail recursion with that, or using recursion or to process a list. And there was 3 methods, all of which had the same declaration, but which reached the same sort of naming and arguments and stuff, but they were each triggered with different when clauses. So one was when you entered into the recursion, the second one was when you were doing all the recursion, and then the final one was called on the last case. And the language did all of this for you. So it was a beautiful way to make the functions really small and very clear and very single purpose, right? You didn't have to check for any of these conditions, you just had it.
It's working smarter, not harder, right? Let
Yep.
the language work for you, which is the opposite of Java, right? Where
I'm not even going to go there. I'm just going to mute myself and not answer that one.
Nice. Did we get through them all?
Did
We
we want
didn't
to come
get-
back to extract transform?
Right.
Yeah.
I want to talk about that one.
Now we gave Jeremy enough time to go through and figure it out, so he's going to explain it to us now.
Jeremy Ward, off you.
So here's the thing about transforms, right? No. I mean, I don't know. I guess I actually think the chapter was confusing. I agree. Like maybe it was harder to follow. I think if you just look at the example again, the example itself at the beginning of the chapter sort of says it all. You're getting that object back just kind of decorated with the different set of data that it can possibly contain. And so, so up above, he's got those methods, but inside of it, he's calling those methods and just giving you back a clone version of that object. I don't know when this is useful to me. I haven't seen like this in the wild. And I think maybe that's the hard part for me to kind of like wrap my head around is like, when will I want to do this in my, in my given language? And so this is one I think I'm going to keep an eye out for. Like, I'm going to see if we can find an example of when I want to have that object kind of decorated with additional data. Because I know it
I think
exists.
if you don't have very strong objects or classes in your language, like I think this is a way to sort of fake it, even though, I mean, he does tell you like the advantage of using objects and classes, if you do have it, is that you don't have to like kind of like cache these dynamic values, which are effectively what they are, because you just call the dynamic method. But because the problem with that is if the source data changes, you have cache things that are incorrect. But yeah, I don't know. I feel like sometimes wrapping everything on a class or an object, and if you do have this mechanic in which like you just do calculations through like your pipeline, like this could be a lightweight manner of keeping some logic together with the data, which I thought that was the most interesting part of that section, was his whole point about make sure that you're always keeping your logic that relates to the data as close to the data as possible so you can find it later. So this is just another way to accomplish that if you don't want to use like an actual class and an object. I have never used it, so I'm just speaking without really having experience.
Yeah, I was like, I was wondering when reading this if this kind of refactoring comes more out of functional programming languages, of which the vast majority, well, all of my career has been spent in object-oriented languages. So I'll preface that I'm not really speaking from a position of experience, but I can imagine having functions that you call one after the other to process data. So this would then maybe be a very powerful way of combining those into a single step.
Yeah, it
Something
feels.
No,
Go ahead.
Go ahead.
No, I was gonna say it feels almost kind of like a mashup of like pipelining transformations on things with like decoration, like Jeremy you were talking about, or when you even do things like view model, like kind of concepts where you're taking something and you're trying to either replace pieces of it or augment it in some capacity. I feel like that's kind of what he's getting at. But yeah, like you said, Jeremy, like I don't really use this as I don't use the premise as a technique usually, so I don't really understand how I would even apply that to stuff that I generally work with.
Something that I did recently is we are calculating, have a process, at the end we calculate a big object, right, with a lot of fields. And I needed to add some performance metrics to that. How long does it take to create this thing? And from different, we are trying to replace one way to do it with another way to do it, right? So I needed, whenever we were returning this object, to have this information also, right? And my first approach is, okay, I can encapsulate this field, this object as a field of a new class, and I return that class, right? But that was not good because this was used in many places. So I extended that class. Nobody else really knows, right? But now, together with the calculation, I'm attaching these performance metrics So it seems to me that is kind of close to what they were suggesting.
Yep.
Right?
I think so.
Yeah. Yeah.
But so now you have a playbook for how to do that, right? I'm just kidding.
Exactly. Now you
I
still
still don't even know.
see if I follow these steps.
Yeah, just follow those steps and you'll end up somewhere. I don't know if it's where you would want it to go, but you will end up somewhere. I can promise you that. Just run your tests in between and it'll all be okay if you read this book, right? Right? Is that the takeaway? No? Okay, cool. Glad. Okay. I think we're at time, so we will wrap it up unless anyone has any last words. Going once, twice. Cool. All right. Thank you all for your participation tonight. I think we learned a lot, chugged through a bunch of these, and it's good to have other perspectives, even on things as simple as renaming variables, which, who knew you could learn more about that? You heard it here, Dev Book Club. All right. Thank you, everyone. Have a good night.
Thank you.
Thank you.
Bye.